Okay, so yesterday we have seen a little bit part of the logic networks. So you have been introduced SOP and POS in the standard form of SOP and POS. And from that standard form of SOP and POS, you should now be able uh, to put it in a truth table. Okay, so okay. So you have been introduced about the SOP, POS, then from that SOP, POS, so you should able to transform it into a standard form by enhancing the algebraic equation. Okay. So for example, the POS, you need to multiply by A dot A bar, which is actually equivalent to 0. So when you do a lot of exercises, actually you can do it very fast. So what are the missing parameters, missing terms? So you need to include it in order to make it in a standard form. And then you should able to transform it into the truth table. And also, if you are given a truth table, you should be able to transform it back to the Boolean equation. So this is the steps in order to convert the standard SOP or POS into the truth table. So for example, if you are given an equation, okay, first step, you convert it expression to the standard SOP or POS. Then you determine the domain and combination of binary value at input. So you determine the combination is 000, 001 or whatever, which represents by the standard SOP or POS. Okay, so then you put the output, okay, which is equal to 1 for SOP. Okay, this is actually representing the code. ABC 111, A plus B plus C is 000 for POS. And finally, you transform it into the truth table. Okay, so step number 2 is determine the domain, the equation maybe. Okay, so this example, okay, just to refresh back what have you learned yesterday. I think yesterday I already showed you one of the example, right? Okay, maybe we will give other example. Okay, still we are in the truth table form. So when you have a standard SOP expression, simply you can transform it into the truth table. For example, here, so the purple part is all representing the SOP. So we have the 5 terms, which is each of it we call the Minterm for SOP. And this is the standard SOP for standard SOP. So we will have the 5 terms here. So if you want to write like this, So it will be very long for this algebraic equation. So we have a way to write it in terms of min terms and max term. So for example, here we have the three terms. So for the max term, which is POS. So actually, parts. So just now, these 5 parts representing the SOP or min term, and another 3 parts or balance of it is representing the POS or max term. So it depends how the question being asked, whether you want to write in the SOP or POS. So it's just when you have included the SOP, all the value is 1, for example, this one. So another 3 or the balance. So in this case, we have 8 possibility. So 8 minus 5. So another 3 possibility is representing the POS. So POS representing the max term, while SOP representing the min term. So the equation, for example, the min term of max term is too long. If you have all 8 or 16, so it will be difficult to write. Okay. So in order to shorten it, we introduce a way to write in terms of min term or max term. Okay, for example, this is the case of 3 inputs. So n equivalent to 3. So you have a 2 to the power of n. So it has a 8 possibility. So that means you can write 0, 0, 0, 0, 0, 1, and so on for this. And if it is in the SOP form, so you can write, for example, A bar, B bar, C bar is equivalent to M0 to represent this. Okay, and a small m. And for the max term, representing the big M. So I will copy paste again the appendix. And it follows from 0 until 7 for this case of 8 possibility. So at the end, for example, M7 is representing the big M7 representing the 111. Okay, how we want to write it? Okay, let's see this example. So this equation, for example, the min term, so F A B C is equivalent to, so you have all the 5 terms, 5 min terms, and actually you can representing it with a small m. So A bar B C is actually, okay, so this is 3, 4, 5, 6, 7. So you can write M3 plus M4 plus M5 and plus M6 and M7. And you can shorten the way of writing it using the summation with a small m and all the number that representing the small m. So in this case, number 3 until 7, which is representing 5 min terms, 5 components of the min terms. Okay, so this is for the case of SOP, which is representing the min term. For the POS is vice versa. Okay, so in this example, so it representing the 3 components or 3 max term. Okay, so if the equation is written like this, it's very long, so you can shorten the right way of writing is like this. using the capital M and the numbers that representing the 0, 1, and 2. So M0 multiplied by M1 multiplied by M2. And this, and to shorten the way of writing, so you can further shorten it into the pi big M, okay, 0, 1, and 2. Okay, sometimes in the question, it's only give the notation. So in terms of Minterms or Maxterm. So if it is given in the Minterm, so also you can transform it into the truth table. And when it given the Minterm and how you want to get the Maxterm, so actually, yeah, if they given the Minterm, you can get the Maxterm. If it's given the Maxterm, you can get the Minterm. And you can play, I can play around with the question. Given the Minterm, get the Maxterm, for example. Given the truth table, get the Minterm. And after that, also after next week, we will introduce maybe about the K-map, where you will transform the truth table to the another table. Okay, example here. F equivalent to summation of M1 to 6. Okay, so question asks, transform it into the standard SOP. So standard SOP here, okay, so you need to transform into the code 001. If I will transform it into code 001, 010, and 101. Betul? 6, silap. Okay, 110. Okay, so if I got the number, so what I will do, always I will transform it into the code. Okay, so you can write it to follow this step, or you can jump directly, transform it into the Minterms of the standard SOP. So depends. Okay, so you can write with this step or transform it like this. So depends on the question what is being asked. And normally, so why I transform it directly to the code, because it will be easy for me to transform it in the form of truth table. Okay, so you know that from this Minterm also, for example, 1 to 6. 1 to 6. Actually, you already know that the maximum number is 6. So in this case, maybe, okay, the maximum n is equivalent to 3. Okay, so that means you have 2 to the power of 3, so you have the 8 possibility. Okay, so you draw the truth table and you know that 1, okay, 1, 2, and 6 is the Minterm. Okay, so when it's given the Minterms, so automatically the others will be 0, okay, and the others will represent the Maxterm. Even from this, actually, from the truth table, you can get the Maxterm notation. Okay, so you know that this is what? This is 0, this is 3, 4, 5, and 7. So that's, you can write the Maxterm notation from the truth table. And if being asked for Maxterm, so you can rewrite it in the standard POS, which representing all the codes. For example, 0 is 000. So normally I will write 000, 011. So 4 is what? 100, 101, and 111, which is representing 00 A plus B plus C. Okay, so please set in your mind that Maxterm is just an vice versa or opposite terms of the Minterms. So if you know the step how to do it in the Minterms, so you should have no problem in the Maxterm. But sometimes, the question being asked just to test your understanding. But normally students will confuse when the question being asked related to the Maxterm. Okay, in this slide, in the chapter 4, so Boolean simplification is again put in this section. So actually, you have learned it in the, it's already included in the chapter 3. Basically, it's the same things. Because of what? Because of, so maybe from the Maxterm or from, you need to do, maybe from the Minterms. So from the standard SOP, you need to do the simplification again, right? So next week, we will proceed with how we want to transform a truth table to a map. So that's why it's really important to transform it into the truth table. But this week, I want to touch about the K-map. So maybe we can see some of the previous quiz, test question, final exam that I have uploaded in the Google Sites. Okay, so maybe next week I will give a quiz, and the following week you will be given a test. Okay, so this example of quiz just to recall back the basic gates and how you can transform it into the truth table. For example, what is the first gate? So kalau tak ingat, tak tahulah ya.
North, north and
no. Conting. Oh ya. No. Aku dia tak boleh conting ni ya. Don't be touch. Oh, read only. So read only cannot conting. Oh, I thought I can draw. So tak boleh. I cannot draw here. Tak best lah. Tak boleh draw. Okay, so this is just example of no gates. So what is the Boolean expression? F equivalent to A plus B, then you have a bar. So then you fill out the truth table. And the second one is the AND gate. So it's just an easy one. And number 2 is a gate, a chip. Okay, So we haven't learned about this. So it start normally a 74 series of gates. Okay, in one chip, normally you have maybe four, two or many more gates. Okay, so your AND gate, for example, it doesn't come in a single chip. It in a single chip may contains, for example, in this case, it has four AND gates. Okay, but later I will introduce this kind of chip. Okay, so this is just a quiz. State the true or false for each of following Boolean equation. Okay, A plus 1 equivalent to B plus 1. Betul ke?
Betul.
Alright. Okay, AB is equivalent to Abba.
Betul.
Okay. UTM plus UITM equivalent to UTM.
Betul.
Betul.
Okay, it's correct. UTM, you 1 plus I. So 1 plus I is 1. So it's equivalent to UTM. But in reality, it's not the same, right? Okay. So KL bar plus C.
False.
So,
Salah.
Salah.
atau salah je kan? Alright. Okay, this is wrong. This is maybe C jawapannya. KL, if you enhance, so you have a KLC, 1 plus KLC. So it's just a KLC. So this just an, so whatever I have in the iPad, I will just open on my iPad. So if I give a quiz, normally it's just an easy one. Quiz 1, quiz 3, quiz 4. Okay, this one is not. Mana tutorial So ini pun semua dah advance nya. I try to open storage account. My dalam OneDrive. Saya nak open saya punya ni apa Google Drive. Tak boleh add. Tak ada pun nampak Google Drive. Tak link kat sini. More location. And we have the Google Drive. So yeah. Okay, dah. Lepas tu hang. Okay. So inilah teknologi ya. Alright. Google Drive. So where is my Google Drive? Hai. Ini email lain. I have 2 email. Okay. Please. Test 1 tak ada pula. Okay. Upgrade a copy. So kalau upgrade, we can okay. Okay, so should be able to draw. Oh, message boleh. Sorry, I just learned. So right now should be able to draw. Why still cannot draw? Oh, pen saya pula tak menyala. Okay, so the example of test. So your test one will be held on 28 April. All right, so sorry, I take time to familiar with the cloud, the gadget. Okay, so the example of test one, bila punya ni saya pun tak ingat. Okay, so normally, so a few questions will be asked about yes or no, ABCD, prove it, and so on. So test normally, okay, for example here, ask you about the binary concept, and number 2 question about the change of binary to decimal and so on. Okay. Then, okay, we go to the gates. Okay, so the example of, okay, figure 1 shows 4 types of logic gates. So you have gate 1, gate 2, gate 3, and gate 4. Okay, which gate is equivalent to input AND gate? Which gate is to input NOR gate? Which input represent the 2 input NAND function? So you have 1, 2, 4 marks here. How you want to do this? How will you want to solve this type of question?
Using the Morgan theorem.
Using a what, Fikri?
The Morgan theorem.
No, you don't need the Morgan theorem. You just need the truth table. Okay? So you just need truth table to solve each of these. So you have, for example, input and output. So you need to solve it one by one. So for example, question number 1, 6-1. So you have the A, B, and F1, Fi, for example. So you just put 0, 0, 0, 1. You have only 2 input, 1, 0, 1, 1. So you know it is an AND gate. So 0, 0 is 0, 0, 1 is 0, 1, 0 is 0, this is 1. Okay, so that's for the first truth table. And then the second truth table is F2. Okay, is NOR gate. So you just put all the possibility. What is NOR? What is NOR? NOR is not and OR. So 0, 0 is 0 for OR, so but it is 1. 0, 1 is 1, then 0. So this 0, 0. So I just put and solve for all. So F3, okay, 0, 0, 0, 1, 1, 0, 1, 1. So none gate. None is not n. So 0, 0 is 0. Then 1. 0, 1 is what? 0. Then 1. Then 0 is 1. 1, 1 is 1. Then you have a 0. So if I make mistake, you just tell me. And you need to do each of these gates in order to determine whether it's the same or not. Okay. So for example, gate 1, A, B, F1. 0, 0, 0, 1, 1, 0, 1, 1. Okay. Be careful, it has a bubble here. Okay, so that's mean 0, 0 as the input. So that's mean 1, 1 as the input. 1, 1 is 1. So 0, 1 is 1, 0. So it is 1. So 1, 0 is also 1. So 1, 1 is 0, 0. 0 plus 0 is 0. And you find out the matching of this. You have the matching. Okay, it seems that this is matched with this. Oh, okay, sorry. So question number 3 is different. Better. Oh, mana pemadam? Okay. So this is different. Question number 3 is asking other question. Alright. So it is not matched in 1 and 2. So we see on the gate number 2 pula. So you have 0, 0, 0, 1, 1, 0, 1, 1. So this is NAND gate. Okay, 0, 0 is 1, 1 is 1. Okay, 1. 0, 1 is 0, 1, 0, 1, 0. 1, 0 is 0. 1, 1 is 1, 1, 0, 0, 0. Okay, so gate 2 is equivalent to this. So it is equivalent to gate 2. And now about gate 3. So A, B, F. So you need to do each of these in form of truth table. So A, B, F. So it is 0, 0, 0, 1. So this one is equivalent to gate 4. And gate 3. And gate 4 is A, B, F. Because gate 3 is output is opposite to gate 1. And gate 4 is the output is opposite to gate 2. So that's why I write very fast. So gate 4 is opposite to gate 2. Okay, so the last question. Use gate 2 and gate 3 to form a two-input NAND function. Two-input NAND function. So how NAND function? NAND function is like this. Okay. So it should have, so this NAND should have like this. So it asks you to use gate 2 and gate 3 only. get 2 and get 3 MB to represent the none. So this one, saya pun tak ingat eh. So how none? None is equivalent to this plus this. Okay. So here this one you need to think to use the transformation of saya tengah fikir ni. Satu. Okay. So for the question number 3, you need to think based on the truth table. And you need to relate soalan ni susah sikit dah. Sikit je. Okay. And you need to relate to this truth table. Okay. You can see that the output of gate number 4 is opposite to this output. So that means this is 1110, this is 0111. And this one, the output is only 1 when it is 00. How we want to combine? So saya pun tengah fikir ni macam mana. If 11 is 0. Mana letak dulu? How we want to mesh? What happen if I put this first, then I combine with this? No, saya salah lagi. So it's gate no one tell me it's gate number 3. It's not gate number 4. Okay. So it's gate number 3. It's not this. It's using this. So that means it's just an opposite of this gate. So gate number 3 is 001. Then you just need to implement the gate. Okay. So actually you can represent this. Patutlah saya lama fikir tadi. Okay. So you are representing this as AB add up with the gate number 3. Just 2 marks. So just like that. Okay, because you know this is 00001. So you want the output is complementary to this number. So that means 0 change to 1 and 1 change to 0. And by putting the input of this F here, F1, and when the output is 0, 0, and when the input is 0, 0. Okay, and you will get the output is equivalent to 1. And when the output is 1, 1, and when the input is 1, 1, so we get the output of 0. So here. So the drawing is just like this. So actually, yeah, so this may be the kind of question that could appear in the test or final exam. So here, the important things is you understand the truth table. Okay, you draw first the truth table. Okay, and then you think how you want to relate the truth table to the question. So just now I mistakenly think this is the gate 3. So this is actually gate 4. So I try just now to relate, okay, the question of gate 2 and gate 3. So nampak susah But with an exercise, so it should be easy. Okay, so this is a standard question. Simplify the Boolean equation. So this one should be easy. A bar, so is equivalent to
0.
0. Okay. So AB, so it's just a 1 plus C, so it's equivalent to AB. So this one, A plus A bar, this one is 1. So A plus 1, so is a bar 1 plus A 0. Yeah. So it is equivalent to A bar. Betul I think it's correct. Okay. So this proven proof that equation equivalent to something blah blah blah. Panjang ni. Yeah. Okay. So if it's too long, so it's your job to shorten it. For example here. Okay. D A C bar plus A bar C plus BC plus ABC. So if you want to write the dot, it's okay. Without the dot, also is understandable. So ABC bar plus A bar BC plus BC plus ABC Ini bar. Okay, so I don't want to show it in detail. So here you can solve it. Okay, so there's another question based on the 2 marks. Okay, obtain the truth table of the function of this SOP. So the example of SOP, but the question doesn't state this is in the SOP form. So the question didn't state as it is SOP or POS form. So but from that equation, you should able to determine this SOP or POS. So when is given the this kind of question, okay. So first thing you need to determine the n. Okay, number of variable there. So you have the A, B, and C. So you have the n equivalent to 3. So you have the 2 to the power of 3. So you have the 8 possibility. So number 2, you need to get the standard form. So here, okay. So the way of writing here, so sometimes so you can write all the variable. Okay. Even this already given you the information of the number of a variable. So sometimes people write F is equivalent A, B, plus C. So without the information of the input. But here, the information of input already given there. So A, B, C is equivalent to, so you need to transform it into the standard SOP. So A bar B, so C plus C bar plus AC, B plus B bar. So then you do the enhancement A bar B C plus A bar B C bar plus A B C plus A B bar C. Okay. And to make your life easier, I advise you to write the code here. 0, 1, 1, 0, 1, 0, 1, 1, 1, 1, 0, 1. It's okay. If you want to sketch or write a little bit small number there, is okay. Then you know already that this is a 3 variable. So you draw the truth table. So A, B, C, F, and you put all the 8 variable here. You see here, we didn't write the word input and we didn't write the word output. It's okay. So the important things is the variable is there. A, B, C, and F is the output variable. So now, since you already have the standard equation, okay, so now you just transform it in the truth table. So you have the 0, 1, 1 is 1, 0, 1, 0 is 1, 1, 1, 1 is 1, 1, 0, 1 is 1, while the others is 0. Okay. So that's how, okay. So this also you can write, but this question didn't ask you to write in the Minterm. So you can also write this in the Minterm. Okay. So I just want to. This is representing the, okay, 0, 1, 2, 3, 4, 5, 6, 7. Okay, if I want to write this in the terms of Minterms, so you have the, what? You have the summation, you have the small m, you have the all the numbers. So here you have the 2, so 2, you have the 3, you have the 5, you have the 7. So this in terms of Minterms. And how about in the Maxterm? You can write also it is equivalent to M 0, 1, 0, 1, 4, and 6. So these terms in the even the but the in this test question, so it didn't ask you to write in the terms of Minterms or Maxterm, but I just added for your further information. Okay, so next the question asks, obtain the minimized expression F in POS. So question asks about the minimized expression in POS. So to get this, nak buat banyak dia punya terms ni.
Terus dia punya table dia.
Okay. So actually from this information also you can transform directly, because this is you extract also from the truth table, right? So this is a POS. So what is it? So you have the first one, A, B, C, A B, C.
A plus B plus C.
A plus B.
A plus B plus C. Then you have the A plus B plus C bar 001 A mana tadi?
A bar plus B
A
plus
bar plus B plus C bar plus A.
No, sir. The third term is A bar plus B plus C.
Saya salah ni.
Ya.
Salah tengok. Dia apa? 4 100. Okay. Then 6. A bar plus B bar plus C. So, but the question asks about to obtain, to minimize. Okay. The question, so this is in a standard form. So you should make it in a minimized form. So you can see that here, okay, A plus B plus C, okay, on these first terms. Okay, so you see A and B is the same without bar. The only change is the C and C bar. So here you can shorten it down into A plus B only. Okay. Okay. And here also you have the A bar on these two terms. Okay. You have the A bar, here A bar, here you have the C, and this is C. So only B is changed from B to B bar. So this one actually you can shorten it into A plus A bar plus C. Okay, hope you understand. So because the change here is only here. So it's enough to shorten it here. You don't need, okay, you don't need to simplify it further, because the question asks you in terms of POS. Actually, you can do this A times A bar, A, C, B, but that one is not in the terms of POS. So here is the simplified form of POS. Okay, so habis. Okay, habis. So I think, so today is, I give a very good example, because we never really discuss about the test. So any question? Kena example lagi?
No, no question.
Okay, understand Understood?
Yes.
Understand.
Yang lain senyapnya.
Penat tu penat.
Alright.
Understand, sir.
Okay, we see maybe ada example. Mana nak cari? Okay, on my file apps. Last year exam for 3 lah. So I just pick up a random. Hopefully, so I pick up randoms means that so I didn't prepare for this class. Tengok tu, memang tak keluar. So actually, most of the question I have seen that before. So tolonglah keluar tolong. Tengok tu, iPad nak buka pun lambat. So sometimes when I teach, it's just a basic workflow. For this case, for example, you have the Boolean equation, you change it into SOP or to POS in a standard form. Then from that, you transform it into the truth table. But question can be manipulated. Okay, for example, in this case, given the SOP equation, then you need to transform into the truth table, and from that truth table, what you can get from in form of POS. Nampaknya tak boleh ni. Terus hang ke apa ni? Terus hang. So terus dia tak keluar. So let's see if I can get what's this? Google Drive, My Drive. Semua keluar kat sini. Google Drive, SOP, My Drive lah. Mana yang kelas ni? Vivo. Final exam, SKE 1223. Oh, this is just ini dia buka ni. Ni final exam ni, bila punya ni? Okay, ni tahun apa? Your senior ni. Okay, ni example terus. Your senior. Tapi tak ada question. It's just example directly. Tak ada question. Kalau if I have a question with the answer, it's okay. Okay, so this just I just go through the answers from your seniors. So last year final exam. So I just want to show you the kind of question. So last year we have the section A and section B. So section A is just a very fast answer. Section B is a longer question. So section A is 1 to 10, maybe 5 marks each. For section B, I think So only 4 questions, which each of the question maybe have a longer higher marks. Okay. Okay, for example, so this just boleh contek ke tak ni? Okay. Boleh draw ke? So ni tak boleh draw pula. Maksudnya boleh edit PDF. Oh, okay. Okay, so example. So this example of question. So for example, the first question asks about this final exam, about the basic concept of frequency. So this is just a 3 marks. So to recall back, F equivalent to 1 over T. So this is back to what you learned in the first week. And then you have the duty cycles in order to calculate the percentage. So this is just a brief idea on the final exam. Then the second question asks about the transformation of binary, decimal, hexa, octa. So it's just a change of numbers. And here you have the additional like gray code or change to binary, which is a section after the numbers. So ini question ni asal apa pula ni? So number 3, okay. Number 3, so to get what? I think number 3, oh, number 3 I think is to shorten from the truth table to get shorten the equation. Okay, so number 4 is related to shorten the equation. Okay, so this is based on the theorem de Morgan. So you need to be expert in changing the theorem. Okay. So for example, this part you have the double bar. Alamak, tak boleh padam. Dah terpadam. And when you change, saya tak tahu betul ke tak ni. Okay, so when it change, so it remove everything the bar, and then you change back the theorem de Morgan, and so I think this is correct. I think. Yeah. Okay, here you have the information about the mean terms and what information you get from here. So here you have the A, B, C. So that's mean 3 input and 2 to the power of 3. And then from that information, you put it in the truth table. So this one, so he may already input put all the value in the truth table. But this one in the design for the further. Okay, yang belakang ni adalah design. Tak jumpa pula. Macam mana nak short? Ni apa ni? Oh. Ni apa? So everything in the folder. So the class and so on I put in folder. Kita mau ikut. Sekarang pukul berapa? 9:30. Lupa pula. Okey, akhirnya jumpa. Okay, so maybe perhaps so final exam dia tak bagus dah, tak sebab dia advance. Okay. So to do the exercise, okay, for this session, so it's better for you to do the exercise so for the test too. Okay. So for example here, edit. Mana PDF ni nak edit? Cancel. So edit PDF. Okay. Nah, tak bagi penting pula. Boleh tak penting?
Cuba pakai fill and sign tu sir.
Fill and sign. Oh, okay. Fill and sign. Tak boleh juga. Boleh? Tak boleh. Kecuali masukkan yang sign ni. Ini sign saya. Dia patutnya edit PDF ni dia boleh edit.
Cuba saya convert ke Word ke.
Oh,
Satu hal pula.
dia kena save ni. Save a copy on this iPad. So, letak dia mana kat mana ni. Student ni punya. Saya save aja kat sini. Okay, kemudian saya buka PDF. Dia scan. Okay, supposed to be now can edit. Tak boleh juga. Okay, tak apalah. So we just go through. So kalau tak bagi nak conteng-conteng. Okay, first question. A, B, C, D. Okay. Equivalent to summation of M 0, 2, 3, 5, 8, 10, 12. Okay, so we have the don't care. Don't care we have learn. So we will learn about this don't care next week. And K-map also we haven't learned. Okay, so for this question, so what information you get? If it being asked for you to draw the truth table. So actually the question also will, the step before you draw the K-map, you still need to draw the truth table. So you here you have the input A, B, C, and D. So directly it show the information that your input, you have the 4 input. So n equivalent to 4. And then 2 to the power of 4. So you have the 16 possibility. So 16 possibilities. So that means you have the 0, 0, 0, 0, 0, 0, 0, 1, and so on. And then you just put the minterms 1, for the case of 0, 2, 3, 8, 10, and 12. And others you put 0. So this just put. Okay, So question number 2, function f a b c d given by the equation that equation. Implement the minimize function in no configuration. Okay, so ini this one. So this one, okay. First, you need to minimize the equation. So next, you only need to use the NOR gates. You only need to use NOR gates. So that's mean after you minimize the equation, okay. So you need to make it suitable for NOR configuration. So that's mean if the equation as n, so you need to convert it into the NOR. NOR, that's mean A plus B and the bar on the top. So that's is the NOR equation. So macam mana nak buat? So saya pun tak pernah buat ni. So macam mana? So sekejap saya kena conteng dululah. Mana pen? Okay lah. So sebab saya pun tak buat lagi. Alright. Okay, so you have around 25 minutes. Okay, you do this as an exercise. So try to think so that the equation come up with a NOR configuration. So I will do this also. And we can discuss it in the next week class. In start of the next week class. Okay. So ini exercise for test 2. So dia patutnya ada exercise for test 1 Mana yang tadi ya? Okay, digital electronics exercise. Okay, exercise for test 1 rupanya dah ada answer. Okay, right now you should already do the exercise. Kenapa dia tak boleh edit? Okay, so this basically the change of number, BCD. Okay, number 10 start with the gates. So buffer saya tak ajar. Implement a buffer using a single input. So pin ni pun saya tak ajar lagi Okay, I didn't teach yet, number 11. So number 12. Okay, so number 12 again. Okay, the same as a previous example. So you need to draw the truth table for each of the gates. So if you don't draw the truth table, it will be difficult for you to answer question number 12. So for example, gate 1 is the complement for gate 4. How could I know? So that means the output should be opposite. The output of gate 4 should be opposite to gate 1. So get 2 has the same function as get 3. So I couldn't know if I don't draw the truth table. So number 13. Okay, the circuit in figure 5, A and B, perform a basic logic function. So what is the kind of basic logic function? And, or, not, no, none. So all this kind of example. So how do you want to solve the problem? So that's mean here you need to derive the equation one by one. Okay, so you need to what is A, B, and you need to draw the truth table. A, B, and F, what is it? And so then after that you relate to the basic gates. So you need to draw the 13A truth table, 13B truth table. Question 14 and 15 is for you to think. Okay, so you have learned the basic gates of 2 inputs. So now you need to implement it in the 3 input. Implement a 3 input AND or NAND, NOR, XOR, and XNOR function using minimum number of 2 input AND or NAND, NOR, XOR, and XNOR gates respectively. Okay, so 14A, you have the 3 input of AND. So you need to implement 3 input AND by using AND or NAND, NOR, and so on. So I think this one, okay, so maybe just 2 input AND. So ini tak ada answer eh. Okay. Oh, ada kat bawah tu. Okay, so answer is there. You can take it as a reference. And also question 15 is the thing you need to think and play around with the Boolean equation. So sometimes the question also asks to use only none or no gates only, without other gates. Okay, so for example 17, of course you need to do the Boolean equation and find out what the output. So what is number 17? Using what? Okay. So for example, number 17 here, you need to do the conversion of NOR 17. NOR gate, you convert it to the NAND gate. OR gate, each of OR gate you convert also. And also use all the NAND gates. So sometimes the question you need ask you to think. Okay, 18 is just an equation, 19 is equation, 20. Okay, get the truth table, write the SOP, POS of standard, and then you do. Yes?
Sir, canonical tu apa? On question 20, number 2.
Tak cakap canonical ni this. Okay, obtain the true function. Write the canonical SOP and for this function, and then simplify them in SOP and POS separately using Boolean or equation. Okay, I think the word question number 2 is the standard form. Okay.
Okay.
I think it's in the standard form. So, but normally it is written standard canonical SOP and POS. And in order to draw the truth table, actually you should already write the standard form. But never mind, maybe, okay, question 22. So you write the standard form, then you simplify it. And then, okay, so this one, the question asks only to use none, or no gates. So you need to think how to change the kind of gates that you need to use. Okay, 21.1 is a Boolean expression. Okay, so the answer is there. Right now you should able to be prepared for test 2, and maybe in the next week or following weeks, if you have question, we can discuss in the class. So normally kan student kan 28 Bila? 28 hari Rabu 28 the test. So normally student will ask to have discussed during class hours. Okay, so maybe you can ask question. If you don't know, maybe on 28 morning, we can have some discussion on before the test. All right. Okay, anyway, you need to do the exercise and also need to prepare for the second quiz. So second quiz I will give on Wednesday or Thursday, probably on Thursday, probably on the Boolean equation and the POS and SOP and truth table. So normally quiz is just a 3 marks, but still you need to study. Okay, so before we end our class, any question?
No, sir.
Okay, so the resources are there in the Google site. So you need to download it and do the exercise. What is the portion of test 1? If I'm not mistaken, it's 15%. Okay. 15, 30, 5 is quiz, and another 15 maybe assignment. If I'm not mistaken, okay, test 1, 15, test 2, 15, quiz 5, so there already 35, another 15 maybe test assignment and e-portfolio, if I'm not mistaken. Okay. Oh, so test 1, I think is up to the KMAP. Okay, until chapter 4 for the test 1 until next week's syllabus. Okay. Okay, with that, thank you very much. See you next week. Assalamualaikum warahmatullahi wabarakatuh. Bye.
Waalaikumsalam.